Alrighty, so today we're going to be having a look at symmetry in the unit circle. Now, we're going to start off by something that we're probably quite aware of, which is that if we have the sine of an angle, theta, that would be the same as the sine of the angle theta plus 2 pi. And just as a reminder why this is, if this is our unit circle here, and we've got some angle theta, let's call it this one here, and I add 2 pi to it, well, what that means is that I've got to do a full rotation, which is pi. Let's do that in blue. So do a full rotation, and then do a little bit more, being theta. So these two y coordinates would be exactly the same. So that is not only true for sine, but it's also true for cosine. And in fact, that's quite a nice little feature of them, is that when you add 2 pi to the angle, it does not change it. And it's also repeatable, meaning it's also plus or minus. Doesn't matter which way. If you go 2 pi angle, well, you're just going to end up where you start off. So these are the first two rules. Let's call them number 1, number 2. That when you add 2 pi to an angle inside a sine or a cosine function, you just get the angle. For tan, it's a little bit different. And this is due to the fact that tan has a slightly different period to the other two functions. So since the period of sine and cosine are both 2 pi, the top two rules make sense. If you remember, the tan period is just a single pi. And so that could be a third rule based on tan. So the tan of theta is equal to tan of theta plus or minus pi. For when you do a half term, you end up with the same thing. Alright, let's look at a few more sort of rules that we can come up with. Next one is going to be to do with the symmetry. So, question is, can we do anything about the sine of negative theta? Well, if I think about what that means, well, let's call this negative theta here, right? This is negative theta. Well, positive theta would be this angle here, right? So we've got these two different ones. Negative theta is this point down here, and positive theta is this point up here. And the question is, can we say anything about these 2 points? Is there any relation? Well, it's easiest to look against the y-axis, right? Right? Because remember, sine is measuring the y-coordinate. It's measuring how far away it is from the x-axis, the y-coordinate, the height. So this point here is the same distance, right? This distance is the same as this distance. The only difference is that this is positive and this is negative. Meaning, when you go the negative angle, that's the same as getting negative the positive angle. Algebraically, it means that often you'll find questions which leave the negative inside the brackets. They'll just move the negative to the outside of the brackets. However, it's also reversible, meaning if you've got a negative on the outside, you can move it to the inside. So that is the sine rule. Let's call that 4. Number 5 is going to look very similar to the top one, except it's to do with cosine. Well, my picture's almost right. The only difference is that when doing cosine, I don't measure the y-coordinate, I measure the x-coordinate. So let's draw in the x-coordinate. Oh, wait, it's the same. This line here tells us how far across it is. And as you see, it is exactly the same. Meaning, the cosine of negative theta is exactly the same as the cosine of theta. And these are our first 5 rules. We have our 3 period rules, and we have our 2 symmetry rules. I want to give us one more. Now the final one is the fact that sine and cosine are actually very, very similar functions. If you look at them on a graph for a second, if you have a think about what the graphs of it, the sine function looks something like this, and the cosine function is almost exactly the same, except it starts a little bit out of sync, right? That's the only difference. They're almost the same function. The only thing is that they've been shifted horizontally. And if you remember from our translations, we can shift things horizontally by affecting the axis. So 6 and 7 kind of come as a bit of a pair. But what we can say is that the cos function, cos of theta, is really just the sine function, but shifted how far? Well, it's been shifted to the left by pi on 2, so minus pi on 2, well actually plus pi on 2, because remember left shifts are plus. But we could also say the opposite thing about the sine. Sine of theta is equal to cosine of theta minus pi on 2. Remember, sine swapping business about translations. So there we go. There's a quick introduction to 7 of the symmetry properties to do with sine and cosine. These are all going to be very, very useful when we're dealing with these functions as we go through this unit. So how can we use them in actually solving problems? For example, I want to simplify this problem over here, which is that I've got the cos of 2 pi plus theta. Well, using the second rule up here, I know that I'm allowed to add 2 pi or subtract 2 pi. So why don't I make this equal to the cos of 2 pi plus theta minus 2 pi? Well, that would just leave us with the cos of theta. Awesome. All done. Let's have a look at the next one. Next one's going to be similar, right? I can do the exact same trick I did, 2 pi minus theta minus 2 pi. Get rid of that pesky 2 pi. And I'm just left with minus theta. But remember, when I've got a minus theta, I can bring the minus outside if it's a sine function, which it is. So I can write this as minus sine of theta. Now, similarly to when we talk about index laws, if I say x to the negative 4, I'd rather you write that as 1 over x to the 4. Same thing happens over here. It's preferable to leave the negative on the outside than on the inside. So often in answers you'll see, even if this is perfectly correct, the more correct looking version is this one down here. So just to be mindful of that. Let's have a look at some more. Alrighty, so this one is the cos of theta minus pi on 2. Well, that's straight up actually one of our rules. So I can immediately go and write, well, this must be sine of theta. However, I think that might be a little bit stark for some of you guys to just see me do that and go, yeah, but why? So let's imagine, right? Let's imagine we're trying to draw this angle, theta minus pi on 2. So let's draw the minus pi on 2 first. So the minus pi on 2 is this angle down here. It's a 90-degree angle, or a pi on 2 angle, but going the wrong direction because it's minus. And then we are working backwards this way. And you can see there that the cos, if this is our angle here, theta, I draw that angle where it normally would be placed. You can actually kind of see that the height matches the length. And so this is how we can use these sorts of facts to sort of prove these points. Now we've kind of done like a rotation sort of business. And so that's why we can say that with certainty. One last one. This one's a bit more tricky, right? Well, the first thing I'm going to do is I notice that I've got more than 2 pi in my power, so let's get rid of it. 5 pi on 2 minus theta minus 2 pi. Can't add these things together though, so let's do that trick we do. 5 pi on 2 minus theta, well, minus 4 pi on 2, right? Because that's how we write it in halves. So I'm left with sine of pi on 2 minus theta. And there's no rule for dealing with this particular relationship, so I'm going to need to draw a picture to assist me. So, unit circle time. Always start with the angle part, so that's pi on 2, which is a 90 degree, and we're going minus. So that means that we're starting here and we're going backwards this way. So let's draw an angle theta. And we're interested in the sine. Let's make it a bit bigger. Let's make it quite a large theta. So maybe around 80 degrees. So getting close to pi on 2. Alrighty. Now, let's think about what we would have gotten if we'd gone the other way, right? Because for the sine, we're getting this little bit here, right? Because that's what sine means. Well, let's imagine instead we went the other way, right? Imagine instead we were going this way. What would theta look like? Regular old theta. So this red angle here is theta, and this blue angle here is pi on 2 minus theta. And so can you see that there's actually a bit of symmetry here, right? This matches this. This width matches this height. And what measures this width? Well, that would be cos, right? Because cos measures how far away we are from the x-axis. So we can actually say for certainty that this is equal to cos of theta. These are not easy. Applying the rules isn't so bad, but really taking the time to being able to do some of these visual proofs is difficult. So good luck. Try to have a go through a few of these questions. Let me know how you go. I'll see you in the next one. Goodbye.